Um, Today I thought about maybe doing a little tutorial or actually maybe just show off how to make logic gates. Um, why logic gates? I'm actually a fan of programming and all these stuffs. And what we actually need in this game from now is that we need AND gate, OR gates, XOR, NAND, NOR, because we want multiple inputs on our engines. We want multiple inputs on our bearings. So I started to look a little around. I found some pretty cool videos on YouTube about AND gates, or actually OR gates, sorry. And I thought, hey, why not going further? So, okay, sorry if that was already made. I don't know. I didn't actually look further. I just wanted to show what we can do with scrap mechanic. I'm gonna show you guys what I'm talking about. We're gonna talk about NAND, which means both inputs to off would produce an on signal. One of the inputs being on produces an on signal, and both being on produces an off signal. And we're going to continue to AND, which means both of the signals needs to be on to have an on signal. OR gate, both or either one of the signals to on produces an on signal. NOR gates, which basically is turning, I don't know, really know how to explain that, but it's most logically turns the input signal to the opposite, um, and also the XOR gate, more mostly known as an exclusive OR, which means it would only be on if either one of the signals is actually on. In comparison to OR gate, where we have either one produces a on signal, but both does not work, where OR does allow. So OR is not exclusive, and that's why XOR exists. So let's take a look at that in the game, and maybe we should try with OR. So just as a reminder, OR means either one of the signal is on, it produces a signal, or actually both. So this is my little world I made to show off all these functions. And here we have the OR gate. I have an engine here. That's a simple timer. And I can have either one of them on, and that engine will make the stop panel rotate. So let's put that on. I can have them both on, or the other one. And if I take them off, everything is off. So as you might see, I always work with a rotating part in front of a sensor, meaning if I stand in front of the sensor, everything goes on. So the whole plan is to have, let me show you the bearings, always two switches connected to two panels that are connected to two bearings. So let's see that. If I activate this one, that front part, the first bearing will rotate enough so that my sensor here detects it and fires the engine. I take the other one, same scenario, it rotates enough so that it sees. And when I rotate them both, it also sees. That would be an OR gate. Why would you need that? Now, let's think about a map where we have one switch here and the other one on the other side of the door. You would need to open your door from both sides. So it's either I use this switch or the switch on the other side of the door, meaning you can always enter your room. Next step is, let me bring Wikipedia back up if it wants. Here, let's go to an AND gate. AND means you need both inputs to produce a true output. So here we go. Nothing on, nothing works. Let's put one on. It doesn't rotate enough so that my sensor sees it. And if I put them both on, it's enough so that the engine fires. Take this one off, doesn't work anymore. This one off, nothing. Just this one, not enough. This one too, enough. It works. Why would we need such a contraption? Because technically, let's say you are preparing a new clutch and you need both users to push on the button at the same time, or actually push on the button all together. So you need an AND gate. AND gates can also be made differently. I saw that on YouTube. I actually came up with a similar idea, but I'm doing it upwards. Oh no, actually, sorry, that's an OR gate. Sorry, I did not say anything. Forget about it. That's an OR gate. I will show you later. So AND gate, very important for having two inputs controlling one engine, two or more inputs. I'm gonna show you guys a 8 input AND gate just a bit later. Let's continue. Let's try a NAND gate. So explanation of NAND gate is technically when it's off, it's on. And when either one is on, it's on. And when both is on, it's off. And actually, we are one on if that's not an AND gate. I think I just made a mistake here. Yeah, it's NAND. Oh, I know what I did. Let me check that. This one. I think I mixed NOR and NAND, sorry. So let's quickly jump to XOR then. We will come back on this one just a bit later. If we go back to XOR, XOR is an exclusive OR. So meaning if I'm off here, nothing works. If either one of these is on, it will work. If both are on, nothing happens. So let's try that. With one, it works. Turn this one off. Turn this one on. It works. Turn it off. Let's try to have them both on, and it's off. Again, just as a reminder, I'm always using 2 bearings, 2 panels, and 2 switches. Turn that off. We have a NOR gate. A NOR gate inverses the signal somehow. So if everything is off, we have a signal, an output. If we have any input being turned on, the output is always off. That's pretty easy to do also in scrap mechanic with that gate. This one was already turned on, of course, because if I turn it off, as we saw, everything is on. So let's try. Turn this one on. Doesn't work anymore. This one, it's off. Let's turn on with this one. It's still off. How did I do that? Actually, I reversed this part. So it's by default on. It's as simple as that. And let's go check the NAND function. I totally screwed up. Sorry guys, actually that wasn't planned. I might have been a bit too fast and I did not check my work. So what we want here is a NAND function. And what is a NAND function? If we read it again exactly so I don't do the same mistake twice, we go to NAND. Means if we don't have any input, we want an output. If we have either one of the inputs on, we also want an output, and if both inputs are on, we want it off. So let me take that on the side so I got it as a reminder. And as we said, that should be on if both are off. So I have different ways of doing that. Oh, let me put that back maybe. And let's just modify this one and make it start at 90 degrees. Here we go. So by default, if both are off, we have an output. If I have, that shouldn't happen, and if both are, wait a second, yeah, let's change that. We want an output when either one is on, but if both not. To make that simple like that, 30 degrees. That's a bit too much. Let's make it 15. So if I use this one, nothing happens. If I use this one, bad. Change that, put it also to 15 degrees. So this one, nothing happens. This one, nothing happens. Both should stop. It doesn't. Why? Because I guess I should go to 30 degrees here, so it goes in front of the sensor, blocking the whole contraption. So this one doesn't stop. This one doesn't stop the contraption. Both of them stops the contraption. That's a real NAND gate. So now I need them both on to stop the logic working. Let me bring you the Wikipedia page back on. If both inputs are off, we have an output. If either one of the inputs are on, we have an output. And if both inputs are on, we don't have an output. So here we go. I'm gonna stop that because I think the game doesn't like to have running motors when you close the map. So let me take them both. So it stopped. Sorry for that, guys. That was my bad. I think I did not check my work correctly. I talked about having OR gates being a bit less complicated, and I actually came up with that contraption. And well, I can explain you this one, or I can also explain you the one I saw on YouTube just lately. So you have other ways to do OR gates. So let's try this one. Pretty cool one. About 8. Let's put bearing a little cube bearing here, here, that one. We place a sensor here in between. And this one should connect the bearings. Here we are. It says me, cool. I think I should build that on a surface, so it's connected as a machine. Sorry. Let's quickly build a surface here. One contraption connected by ground. So let's do that again. Here we go. That says me. Let's block it. Here we go. And here we need a block. Here we go. So, and maybe let's put an engine here. Let's put something here, a little bearing here. Let's put our panel here. Let's connect our motor here, connect the sensor to the motor, and we're gonna put some engine full. Now we're gonna need some switches, and here we go. We connect that one to that one, this one to this one, connect one switch, connect the other switch, and let's put that, I don't know what direction, it's always the same with that game. Yeah, that's correct. And let me guess, this one's on the other side, of course, normal. Here we go. We are off by default, and if I press, let's go 15 degrees down, and same for this one, if I press, let's go 15 degrees down. So what happens? I press this one, the sensor fires. If both are on, still doesn't change a damn. It's an OR gate. If this one comes up, the sensor still sees. OR gate. Technically, that's what I lately saw on YouTube, and I think it's a bit nicer to have it laying. I can't remember the name of the uploader, sorry for that. I think it's nicer looking this way than the way I did it upwards, but well, mine still works if you want to see it. I did actually the same, but looking upward, and either one of them does trigger the opening. Let's take a look at this one. I was speaking to you guys about AND gate. We saw it here. That's a working AND gate, meaning you need both inputs to be turned on in order to have an output. That's with two switches, and I made some better ones. Let's take a look at first this one. That's a 4 switch, and you need a code to enter. If I do that, nothing happens. Let's try this one too. Nothing. Let's try that. It works. Take either one of them away. It's closed again. How did I do that? I will show you. Simply a bit higher contraption. instead of 2, I have 4 bearings. And you have to make sure that a wrongly turned on switch does turn your whole contraption in the wrong direction, and when you have a correctly placed switch, turn it towards the sensor. That's how basically it works. So if we look here right now how it looks, the shape of that of those beans. Let's take a look. If I turn the correct switches on, you can see that we turned on the correct direction, meaning this sensor sees the beam. Let's take a look at this one. This one is a bit more impressive. It's an 8 switch. If I only knew the code, I don't remember what I actually did. You can try for ages. You need the correct combination. Wait, let me check on my papers. I think I wrote it somewhere. No, yeah. It would be 1 1 0 1 0 1 0 1, and here we go. We opened the bunker. We opened the chest, and we also closed the door, by the way. Anyway, let's close it again. Let's decode it, and let's have a look at that monster. Here we go. And that's exactly the coding. So, see the form? Let's try to put the correct code in. Of course, I won't be able to go out, but anyway, 1 1 0 1 0 1 and 1 works. Let's go out here. Yeah, cool. Here we go. See, the whole contraption just turned and made the sensor see it. Looking at that, I have 8 bearings, 8 panels, going to 8 switches, and if the sensor sees, it triggers the opening. If I change just one switch to something else, let's take this one off, the door closes, the other one opens, because our contraption here is not in correct direction and the sensor doesn't see it anymore. As you can see here, I have turned in the wrong direction, meaning I'm not coming in front of the sensor anymore. So that's how you would build bigger AND gates. You can of course also build bigger OR gates if you want, pretty easily. Let me just close that hatchback. So yeah, of course, you don't want. There we go. That's a big AND gate, and let's quickly check if you guys just want maybe a bigger OR gate. That one, let's put that back and put a bearing on it. The panel, let's connect the bearing to the motor. Let's put some engine on, and here we go. What do we want? We want, let's say, 4 switch OR. So we build exactly the same. way. Here we go. Here, 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 here. We said we wanted 4 switches, right? All right, let's make them in line. Here we go. Let's connect that one to that one. This here. Let's connect that here. Oh, let's close the site. Wait. Oops. Connecting the bearings is not a bad idea too. Here, here. Let's make this one minus 30, and it was plus 15, right? Exactly. And this one plus 30 minus 15. That's our OR gate working. Let's try to make it 4. Let's make it here. That one. That. No. I rather have things crossed. Looks nicer. That way. Try that one here. That. That. That one. Let's connect the bearings. Here we are. Here we are. And I think it's gonna be the other way around, so let's do it this way. Yeah. And this way. Here we are, bigger OR gate. Let's connect that one here, that one there. And here we go. We have 4 inputs OR gates. So either one of these will trigger the motor, or all of them. Of course, it's up to you, or just one, or just maybe the last one, or stuff like that. It just works. That's how you build OR gates bigger. And you can go on and on. Just know that the sensor does see a distance of 10 blocks. Of course, here I already lose 2. I could put the sensor maybe a bit closer, meaning I can have, yeah, if I'm clever enough, I could have maybe 10 switches. Maybe even more. Don't know. Have to try. Also, maybe what I just want to show you guys, because I've been talking about that just in the beginning, is those gates that are timers, delayers. Special thanks to Vert Andrew that showed them to me when we were trying to build a lift on his map. And that dude here does delay your input. So let's make that quick. Let's make it ground. And let's build just a bearing here. Let's put a sensor here. Let's place a display panel here on the bearing, of course. Let's connect that to the bearing. And as you can see, I do trigger the whole thing and it's bad, so I usually hide it like this, so I can go in front. It does not trigger anything anymore. Let's quickly place something that turns and makes noise. Here we go. Little engine is here. It goes to the sensor. Let's put some engine on. And now what happens is I need a switch, of course. So if I press the switch, I want this to rotate. Let's check the correct direction. I don't remember if it's that one. Yeah, it's that one. Correct. It can be either used for a timer or a delayer or things like that. So now say I connect that panel to that switch. So if I use the switch, it will take a little delay until it turns on. Of course, I can increment that delay by just putting maybe either, okay, let's put that back to 90 and let's say very slow. That would make a very slow reaction to the switch. But you could also make timers. Yeah, timers. Why not timers? Let's put that back a bit up. And here, put it in an inverted direction so it inverts our signal. If you want to make a door that closes itself after you went through, you would use exactly that. So if I use the switch, it goes down, turns the engine on, will wait a little, and of course, soon should go back up. Do it. Yeah, see, it does it. Of course, it's a bit long, I know, and all that. You can tweak all that system all you want. Let's go maybe a bit faster, and let's put that maybe a bit closer to the start, like here. And here we go. And turn that on. And it turns off. And the other direction does work, so you don't need to bother to have your switch on or off. It works in both directions. So guys, I just hope you enjoyed these functions I just showed you. That would be it for today. Just a quick reminder, we've seen NAND functions, magic. We've seen AND functions with 2 inputs. We have seen with up to 8 inputs on the other contraption there. We've seen XOR, and we've seen NOR. Just feel free to improve that and share with the rest of the community if you come up to better solutions or smaller contraptions for all these functions. So I think these functions are really needed as we can use more inputs, more than one input to a single panel or engine. And I think it's needed to have, like in this case, a gate that opens from both sides. Yeah, that works. Okay, guys, thanks for watching. Hope you enjoyed it, and feel free to contact to do whatever you want. Just let me know if you have improvements or if you have ideas or if I plagiarized any of you. I just hope. I'm sorry for the guys I forgot the names. Thanks to Vert Andrew for the timer gate, and thanks to the YouTube uploader for that basic AND gate I just showed, OR gate I just showed here. And sorry if I don't remember your name. I hope you don't want to kill me now. Yeah, it's bad. Sorry, but thank you anyway. So guys, bye bye.